warehousing, or we can say introduction to data warehousing. Data warehouse introduction: characteristics, architecture, scheme and modeling, differences between operational data, database system and data warehouses. So let's go for thinking item set, data set combo and frequent items. So all these are related to the data item set. This is what we need of data warehouses. What is a data warehouse? Data warehouse is an environment, not a product. Data is often scattered across different databases. It needs dataware to get complete information. It is aimed at effective integration of operational databases that enables strategic use of data. Basically, it integrates various heterogeneous data sources like RDBMS, flat files, and online transaction records. It requires performing data cleaning and integration during data warehousing to ensure consistency in naming conventions, attribute types, and among different sources. We can also say that a data warehouses is basically a purpose of integrating these things. We can say that data warehousing is just a separate from DBMS, which stores a huge amount of data which is typically collected from multiple heterogeneous sources. The goal is to produce statistical results that may help in decision making. For example, a college might want to see quick different results like how the placement of students has improved over the last 10 years in terms of salaries and count. So it is considered as a data warehouse. So, data warehousing integrates data and information collected from various sources into one comprehensive data. इसमें भी example given है customer information from organizations, point of sale systems, its mailing list, websites and comment cards, etc. So data warehouse is a centralized storage system or central repository for storing, analyzing information, interpreting of data in order to facilitate better decision making. A data warehouse is a type of data management system that facilitates and supports business intelligence activities, specifically analysis. It is primarily designed to facilitate searches and analysis, usually contain large amounts of historical data. So what it is a primarily designed to facilitate searches and analysis, usually contain large amounts of historical data. We can see some examples also: investment and insurance companies to analyze customer and market trends and LER data patterns. Retail chains used for marketing and distribution to track items, examine pricing policies and analyze buying trends of customers. In healthcare, where to generate treatment reports, share data with insurance companies and medical units. In airline, operation purpose like crew assignments, route profitability, frequent flyer program promotions. In banking, to manage resources available on decks effectively. In public sectors, used for intelligence gathering to maintain and analyze text records, health policy records. And in telecommunications, used for product promotions, sale decisions and to make distribution decisions. So all these are the areas where the data warehouse is used frequently. You can see in telecommunications, you can see in public sectors, you can see in banking, in airline, in healthcare, in retail chains. All are these the areas, the fields where a data warehouses is used in very frequently. Data warehouse system has another name also. We can see that data warehouse, decision support systems, executive information system, management information system, business intelligence system, analytic application. So all these are the some of the other names of data warehouse. Why? Because these systems include some of the data or the information. They regularly store and retrieve the information or the data from their system, and they can fetch or they can retrieve or they can collect the data or the information from external and internal sources, and after that they can store those data and information for the future purposes only. So other definition, we can say a data warehouse is a single, complete and consistent store of data obtained from a variety of sources and made available to end users in a way they can understand and use in a business context. Are you understanding what this first statement is saying? It can be a complete, single and consistent store. The storage area where all the data is stored from the variety of sources made available to end users for the business context. A data warehouse is a collection of corporate information derived directly from operational systems and some external data sources. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management decision-making process. So it is very subject-oriented. It is integrated of some of the terms. It is time-variant, and also it supports management for decision-making process. A data warehouse, we are learning that a data warehouse can be defined as a collection of organizational data and information extracted from operational sources and external data sources. So जो भी हमारा डेटा है, इंफॉर्मेशन है, जो भी हमारे ऑर्गेनाइजेशन के लिए हेल्पफुल है, ऑपरेशनल सोर्सेज को देखते हुए, एक्सटर्नल सोर्सेज को देखते हुए हमारा जो कलेक्शन हो रहा है वो एक तरीके से डेटा वेयरहाउस ही है. यू कैन सी मॉडर्न डेटा वेयरहाउस है Hadoop, data science algorithm, HDFCs, NoSQL applications, relational data sources, flat files and long files, CSV, web applications, social medias, data warehouse, analyticals, data mart, reporting tools, custom apps. All these are worked together as for collection of data and the information. How data warehouse works. Data warehouse works as a central repository where information arrives from one or more data sources. सबसे पहला क्या है, एक तरीके से ये एक ऐसा रिपोजिटरी एरिया है जहाँ पर हर एक तरीके की इंफॉर्मेशन, हर एक टाइप की इंफॉर्मेशन और डेटा आती है, अराइव होती है फ्रॉम वेरियस एक्सटर्नल और इंटरनल सोर्सेज. Data flows into data warehouse from transactional systems and other relational databases. जो भी अदर रिलेशनल डेटाबेसेस हैं, कुछ सिस्टम्स हैं, वहाँ से डेटा का फ्लो होता है. डेटा में बी स्ट्रक्चर्ड, सेमी स्ट्रक्चर्ड एंड अनस्ट्रक्चर्ड डेटा. तो डेटा किसी भी फॉर्म में हो सकता है, किसी भी टाइप में हो सकता है, और वो चाहे तो वो स्ट्रक्चर्ड फॉर्म में हो, सेमी स्ट्रक्चर्ड फॉर्म में हो, अनस्ट्रक्चर्ड फॉर्म में हो. क्योंकि बिकॉज फ्रॉम वेरियस सोर्सेज वी कैप्चर द डेटा, दैट्स वाई इट कैन बी इन द अनस्ट्रक्चर्ड फॉर्म, स्ट्रक्चर्ड फॉर्म और सेमी स्ट्रक्चर्ड फॉर्म. It is processed, transformed and ingested through BI tools, SQL clients and spreadsheets. Some of the business intelligence tools, some of the structured query languages, some of the spreadsheets, some of the other things, that data is transformed, processed and ingested. Data warehouses contain multiple databases and data is organized into tables and columns in each database. हर एक डेटा वेयर हाउस में एक अपना लार्ज बल्क में एक डेटाबेस तैयार होता है और वो डेटा इस तरीके से ऑर्गेनाइज किया गया है टेबल्स, टेबुलर्स की फॉर्म में या कॉलम्स की फॉर्म में. डेटा स्टोर्ड इन वेरियस टेबल्स डिस्क्राइब्ड बाय स्कीमा एंड क्वेरी टूल्स यूज द स्कीमा टू डिटरमाइन विच डेटा टेबल टू एक्सेस एंड एनालाइज. Data stored in column describes the data such as integer, डेटा फील्ड, स्ट्रिंग एक्सेट्रा. तो कोई भी हमारी स्कीमास हैं, क्वेरी टूल्स हैं, तो डेटा स्टोर जो इसमें वेरियस टेबल्स में होता है वो इन सारी स्कीमास को, क्वेरी टूल्स को यूज करता है टू डिस्क्राइब देमसेल्व्स, टू एनालाइज एंड टू एक्सेस देमसेल्व्स. एंड ऑल्सो डेटा स्टोर्ड इन कॉलम डिस्क्राइब्स द डेटा सच एज इंटीजर. तो टेबल में जो डेटा हमारा स्टोर्ड हो रहा है वो स्कीमा और क्वेरी टूल्स को डिफाइन कर रहा है, और जो कॉलम में हमारा डेटा स्टोर्ड हो रहा है वो हमारे इंटीजर, डेटा फील्ड या स्ट्रिंग को डिफाइन कर रहा है. So data warehousing makes data mining possible. डेटा माइनिंग का मतलब समझते हैं आप. डेटा माइनिंग इज द टर्म वेयर यू सेलेक्ट द रेलेवेंट इंफॉर्मेशन फ्रॉम द कलेक्शन ऑफ डेटा. So before learning the characteristics, we can also learn about the issues occur while building the warehouse. कोई भी डेटा वेयर हाउस बनाने के लिए कुछ इश्यूज हमारे अकर होते हैं. वो ये होते हैं when and how to gather the data. In a source-driven architecture for gathering data, the data sources transmit new information either continually as transaction processing takes place or periodically. In a destination-driven architecture, the data warehouse periodically sends requests for new data to the sources unless updates at the sources are replicated at the warehouse. So two-phase commit is usually far too expensive to be an option. So data warehouses typically have slight out of data. So however, this usually not a problem for decision support system. So this issues may be occur when and how to gather the data. नेक्स्ट इज व्हाट स्कीमा टू यूज. ये इशू भी आ जाता है एक डेटा वेयर हाउस वर्क करने में कि किस तरीके की स्कीमा को आप यूज करना चाह रहे हैं. डेटा सोर्सेज दैट हैव बीन कंस्ट्रक्टेड इंडिपेंडेंटली आर लाइकली टू हैव different schemas. In fact, they may use different data models. Part of the task of a data warehouse is to perform schemas integration and to convert data to the integrated schema before they are stored. As a result, the data stored in the warehouse are not just a copy of the data at the sources. Instead, they can be thought of a materialized view of the data as the sources. So, we have to find out which type of schema has to be used while in data warehouses. Next is the data transformation and cleansing. The task of creating and pre-processing data is called a data cleansing. We can also say that data sources often deliver data with numerous minor inconsistencies which can be corrected. For example, names are often misspelled, addresses may have street, area or city names misspelled, or postal codes entered incorrectly. So these can be corrected to the reasonable extent by consulting our database of street names, postal codes in each city. So, the approximate matching of data required for this task, and this refers to a fuzzy lookup. How to propagate and update. Updates on relations at the data sources must be propagated to the data warehouse if the relations of the data warehouse are exactly the same as those at the data sources. Propagation is straightforward if they are not. The problem of propagating updates is basically the view maintenance problem. So, how to propagate the updates of the data warehouses? What data to summarize? The raw data generated by a transaction processing systems may be too large to store online. However, we can answer many queries by maintaining just summary data obtained by aggregations on a relation rather than maintaining the entire relations. So for example, instead of storing data about every sale of clothing, we can store total sales of clothing by item name and category. So तो ये हमारा एक समराइजेशन ऑफ डेटा का भी इशू अकर हो जाता है while working on the data warehouses. So yes, so these are all the things how data warehouse works. So here are the characteristics of data warehouse. Subject oriented. It provides a topic wise information rather than the overall processes of a business, that is the sales, the inventory, the promotion, etc. So this is the characteristics of data warehouse ki it should be according to the subject the information. Integrated. DW is developed by integrating data from various sources and a consistent format. So all the data is integrated from varied sources into a consistent format. It is stored in data warehouse in a consistent manner in terms of naming, format and coding, which facilitates data analysis. Non-volatile in nature, the data once entered into a data warehouse must remain unchanged and all data is read-only. तो जो भी आपका डेटा है वो अगर एक बार डेटा वेयर हाउसेस में कलेक्ट हो जाता है तो वो बहुत ही मुश्किल से चेंज हो पाता है, दैट्स व्हाई वो नॉन वॉलेटाइल इन नेचर होता है डेटा वेयर हाउस. Time variant. Data stored in a data warehouse is documented with an element of time, either explicitly or implicitly. It is exhibited in primary key with the element of time like day, week, etc. So these are all the characteristics of data warehouses. Some of the types of data warehouses. Enterprise data warehouse. It serves as a key or central database that facilitates decisions, supports services throughout the enterprise. It provides access to cross-organizational information, offers a unified approach to data representations. Operational data store, it prefers for routine activities like storing employee and records. Data marts, it is a subset of data warehouse built to maintain a particular department, region, or a business unit. Every department of a business has a central repository or data mart to store data. So all these are the types of the data warehouses. We can say that EWD, ODS, data mart, ये क्या है? ये सारे types ही तो हैं database के. और इसका क्या है, you can also say that some other data warehouses, like you can see in the pictures, there are the operational systems can be marketing, जहाँ operations performed होते हैं, ERP, SCM, external data, sales, marketing. फिर कुछ इंटीग्रेशन लेटर्स होते हैं जो स्टैगिंग एरिया होते हैं या फिर इन चीज़ों को फॉलो अप करते हैं. फिर वो डेटा वेयर हाउस होता है, तब जाके वो डेटा वर्ल्ड चीज होती है. और फिर डेटा मार्ट्स और स्ट्रेटेजिक मार्ट्स होता है जहाँ पे डेटा माइनिंग की जाती है. सो दिस इज द प्रॉपर डेटा वेयर हाउसेज वर्किंग. अब बात करते हैं डेटा वेयर हाउसेज वर्सेस अ डेटाबेस. व्हाट इज द डिफरेंस बिटवीन दीज टू, वी कैन से दैट. और इन दोनों में क्या फर्क है, क्या हमारा डेटाबेस क्या है और क्या हमारा डेटा वेयर हाउस है. तो अगर कैरेक्टरिस्टिक्स के रिगार्डिंग बात करें, सुटेबल वर्कलोड के रिगार्डिंग बात करें, तो डेटा वेयर हाउस एनालिटिक्स है, रिपोर्टिंग है और हैविंग अ बिग डेटा. बल्कि ट्रांजैक्शनल डेटा के पास सिर्फ ट्रांजैक्शनल प्रोसेसिंग ही होती है. डेटा सोर्स की रिगार्डिंग कैरेक्टरिस्टिक्स के रिगार्डिंग बात करें तो डेटा कलेक्टेड एंड नॉर्मलाइज्ड फ्रॉम मेनी सोर्सेज इन डेटा वेयर हाउस. बट इन ट्रांजैक्शनल डेटाबेस डेटा कैप्चर्ड एज इज फ्रॉम सिंगल सोर्सेज सच एज ट्रांजैक्शनल सिस्टम. Data capture. Data capture in data warehouses, bulk write operations typically on a predetermined batch schedules, but in transactional database optimized for continuous write operations as new data is available to maximize the transaction throughputs. We can also say that in data normalization, denormalized schema such as star schema or snowflake schema is followed in data warehouses. But in transactional database, highly normalized static schemas are followed. डेटा स्टोरेज की बात करें तो ऑप्टिमाइज्ड फ्रॉम सिंप्लिसिटी ऑफ एक्सेस एंड हाई स्पीड क्वेरी परफॉर्मेंस यूजिंग कॉलमनार स्टोरेज. बट इन ट्रांजैक्शनल डेटाबेस ऑप्टिमाइज्ड फॉर हाई थ्रू आउट राइट ऑपरेशंस टू अ सिंगल रो इंटेड फिजिकल ब्लॉक. अगर डेटा एक्सेस की बात करें तो डेटा वेयर हाउस ऑप्टिमाइज टू मिनिमाइज इनपुट आउटपुट एंड मैक्सिमाइज डेटा थ्रूपुट. But in transactional database, high volumes of small read operations are performed. डेटा की बात करें तो रिलेशनल डेटा फ्रॉम ट्रांजैक्शनल सिस्टम्स, ऑपरेशनल डेटाबेसेस एंड लाइन of business applications. In data lake, all data including structured, semi-structured and unstructured data is, you can see. तो डेटाबेस में क्या है, अ कॉमन डेटाबेस इज बेस्ड ऑन ऑपरेशनल और ट्रांजैक्शनल प्रोसेसिंग. ईच ऑपरेशन इज एन इंडिवाइजेबल ट्रांजैक्शन. ये हमारे डेटाबेस में है. डेटा वेयर हाउस में क्या है, अ डेटा वेयर हाउस इज बेस्ड ऑन एनालिटिकल प्रोसेसिंग. Generally, a database stores current and up-to-the-date data which is used for daily operations, whereas in data warehouse maintains historical data over time. Historical data is the data kept over years and can use for trend analysis, make future predictions and decisions. So in database it is generally application specific, but a data warehouse is integrated generally at the organizational level by combining data from different databases. For example, a database stores related data, such as student details in a school, whereas a data warehouse integrates the data from one or more databases so that analysis can be done to get results, such as the best performing school in a city. तो डेटाबेस क्या हुआ, एक पर्टिकुलर स्कूल को लेकर, उसके डेटा को लेकर, उसके स्टूडेंट्स को डेटा को लेकर एक ऐसा रिलेटेड डेटा बनाया गया. बट एक डेटा वेयर हाउस क्या है, सारे स्कूल्स का जो डेटा आया और उससे क्या एनालाइज होके रिजल्ट निकला, वो डेटा वेयर हाउस का काम है. So constructing a database is not so expensive, but constructing a data warehouse can be expensive. Are you understanding what is the differentiate between a data warehouse and a database? So a data warehouses versus a data lake. In the characteristics of data, relational data from transactional systems, operational database and line of business applications are applied in data warehouses. Whereas in data lake, all data including structured and semi-structured and unstructured data is used. Schema की बात करें तो often designed prior to the data warehouse implementation but also can be written at the time of analysis. But in data lake, it is written at the time of analysis only. प्राइस एंड परफॉर्मेंस की बात करें तो डेटा वेयर हाउस फास्टेस्ट क्वेरी रिजल्ट्स यूजिंग लोकल स्टोरेज, वेयरएज इन डेटा लेक क्वेरी रिजल्ट्स गेटिंग फास्टर यूजिंग लो कॉस्ट स्टोरेज एंड डीकपलिंग ऑफ कंप्यूट एंड स्टोरेज. तभी हमारा फास्टेस्ट क्वेरिंग है और यहाँ पे क्वेरी रिजल्ट्स मिलते हैं. डेटा क्वालिटी की बात करें, हाईली क्यूरेटेड डेटा दैट सर्व्स एज द सेंट्रल वर्जन ऑफ द ट्रूथ. इधर डेटा लेक की बात करें तो एनी डेटा दैट मे और मे नॉट बी क्वेरीड, दैट इज द रॉ डेटा. यहाँ पे क्या होगा, आपका जो डेटा होगा वो बहुत ही हाईली क्यूरेटेड होगा डेटा की क्वालिटी, और यहाँ रॉ डेटा होगा. यूजर्स की बात करें तो डेटा वेयर हाउसेस को बिजनेस एनालिस्ट यूज कर सकते हैं, डेटा साइंटिस्ट यूज कर सकते हैं, डेटा डेवलपर यूज कर सकते हैं. बट डेटा लेक क्या है, इट कैन बी यूजिंग क्यूरेटेड डेटा, डेटा साइंटिस्ट, डेटा डेवलपर्स, डेटा इंजीनियर्स, डेटा आर्किटेक्ट्स, एनी टाइप ऑफ the person who is working on data can use in the data lake. Analytics को क्या बोलेंगे, batch reporting, BI and visualizing. Here machine learning and exploratory analytics, data discoveries, streaming, operational analytics, big data and profiling analytics is will be used. Now we can say about the data warehouse components. A data warehouse has 4 components: load manager, warehouse manager, query manager, end user manager, or end user access tools, we can say that. So these are the some of the components of a data warehouses. We can also say that there are some other benefits and some other advantage also, but first of all we will discuss about the components. The first 4 components of the data warehouses are the load manager, जिसे हम बोलते हैं फ्रंट कंपोनेंट. इट परफॉर्म्स विद ऑल द ऑपरेशंस एसोसिएटेड विद द एक्सट्रैक्शन एंड लोड ऑफ डेटा इनटू डेटा वेयरहाउस. Warehouse managers, it performs operations associated with the management of data in the warehouse. It performs operations like analysis of data to ensure consistency, creation of indexes and views, transformations, merging of source data. Query manager, it is a backend component. It performs all operations related to management of user queries. तो जो लोड मैनेजर था, क्वेरी मैनेजर था. लोड मैनेजर फ्रंट कंपोनेंट देखता था, एक्सट्रैक्शन एंड लोड ऑफ डेटा, और क्वेरी मैनेजर हमेशा यूजर्स की क्वेरीज को फॉलो अप करता था. एंड यूजर एक्सेस टूल्स, इट इज कैटेगराइज्ड इनटू 5 ग्रुप्स लाइक डेटा रिपोर्टिंग, query tools, application development tools, EIS tools, OLAP tools and data mining tools. So these are all the end user access tools. So जो data warehouses के components हैं वो यही 4 components हैं कि एक load manager होना ज़रूरी है जो कि first front component बन के काम करे, एक warehouse manager होना चाहिए जो कि सारे operations को associate कर सके management of data से, analysis कर सके सारे operations को, इंडेक्सिंग, व्यूज, ट्रांसफॉर्मेशन कर सके, और क्वेरी मैनेजर होना चाहिए जो कि एज अ बैकएंड कंपोनेंट वर्क करे, और एक एंड यूजर टूल्स, एंड यूजर एक्सेस टूल्स जो कि सारे टूल्स को यूटिलाइज कर सके. अब डेटा वेयर हाउसेस के टूल्स कौन कौन से हैं? डेटा वेयर हाउसेस एप्लीकेशंस कैन बी कैटेगराइज्ड एज क्वेरी एंड रिपोर्टिंग टूल्स, एप्लीकेशन डेवलपमेंट टूल्स, data mining tools, and OLAP tools. Some popular data warehouse tools are Xplenty, Amazon Redshift, Teradata, Oracle 12c, Informatica, IBM Infosphere, Cloudera, and Ponoply. So these are all the popular data warehouse tools will be used in most of the organizations, and their applications can be categorized in these forms: query and reporting tools. So let's start some of the benefits of data warehouses. There are several benefits of data warehouses for end users, like this improved data consistency, data quality, and accuracy. We can also say that this using a data warehouse can improve the data consistency, the data quality they have, and also the accuracy. Better decisions, better business decisions, easier access to enterprise data for end users, better documentation of data, historical data analysis, reduced computer cost and higher productivity, enabling end users to ask ad hoc queries or reports without deterring the performance of operational systems, collection or consolidation of related data from various sources into the place. Or you can also say that to understand the business trends and make better forecasting decisions. The data warehouses are designed to perform well enormous amounts of data. The structure of data warehouses is more accessible for end users to navigate, to understand, and query. Queries that would be complex in many normalized databases could be easier to build, maintain in data warehouses. Data warehousing is an efficient method to manage demand for lots of information for lots of users. And data warehousing provides the capabilities to analyze a large amount of historical data. So basically it works on the historical of data. It is features like centralized data repository, data integration, historical data storage, query analysis, data mining. All these things can be done by the data warehouses. So you understanding what are the benefits we are getting after using the data warehouses in the organization? So here are some of the advantages of data warehouse. It allows business users to quickly access critical data from some sources. It provides consistent information on various cross-functional activities. It helps to integrate many sources of data to reduce stress on production system. It helps to reduce total turnaround time for analysis and reporting. It helps a large amount of historical data and helps user to analyze different time periods. Restructuring and integration, making it easier for user to use for reporting and analysis. And or we can also say that intelligent decision making with centralized data in warehouses, decision may be made more quickly and intelligently. Business intelligence provides strong operational insights through business intelligence. Historical analysis, this is also an advantage in where you can predict the trend. Analysis are made easier by storing past data. Data quality, it guarantees the data quality and consistency for trustworthy reporting. Scalability, capable of managing massive data volumes and expanding to meet changing requirements. Effective queries, fast and effective data retrieval is made possible by a optimized structure. Cost reductions. Data warehouses can result in cost savings over time by reducing data management procedures and increasing overall efficiency even when there is a setup cost initially. Data security. Data warehouses employ security protocols to safeguard confidential information, guaranteeing that only authorized personnel are granted access to certain data. So all these are the advantage of data warehouses. They are business intelligence, historical analysis, data quality, scalability, effective queries, cost reduction, intelligent decision making, large amount of historical data. All these are the advantage of data warehouses. Now, disadvantage of data warehouses. Data warehouses can be outdated relatively quickly. They are difficult to make changes in data types and ranges, data source schemas, indexes, and queries. Data warehouses seem easy, but actually it is too complex for average users. Sometimes warehouses users will develop different business rules. Organization need to spend lot of their resources for training and implementation purposes. This is not an ideal option for unstructured data. So ये कुछ disadvantage हैं data warehouses की. And also we can say that it is very costly. Building a data warehouse can be expensive, recurring significant investments in hardware, software, and personal complexity. Data warehousing can be complex, and business may need to hire specialized personnel to manage the system. Time consuming. Building a data warehouse can take a significant amount of time, requiring business to be patient and committed to the process. Data integration challenges. Data from different sources can be challenging to integrate, requiring significant effort to ensure consistency and accuracy. Data security. Data warehousing can pose data security risk, and business must take measures to protect sensitive data from unauthorized access or the breach. So there can be more applications in different sectors like e-commerce, telecommunication, transportation services, marketing, distribution, healthcare, and retail. So basically these are some of the disadvantages of data warehouses. So this is the overall structure of data warehouse. This is, we can say, single tier structure. This is the basic structure. Here you will find the databases, the other data inputs, the update new data, cleaning, and then reformatting. Then you will find it in all the data warehouses. Then from this data warehousing you will use the other tools like data mining tool, decision support system tool, OLAP tools. So then this tools then then it will go to the database. Sample data warehouse architecture. This is the logical data warehouse architecture. So yes, these are the sample data warehouse architecture. These are the logical data warehouse architecture. You will see some production databases, applications, data warehouse, and data marts, streaming database, unstructured data, ESP, big data stores, social media database, private data, and external data. And also some of the production applications, analytics and reporting, internal portal, mobile apps, website, and dashboard. All these are the terms where you will find the logical data warehouse architecture. This is the two-tier architecture. Here you will find some of the sources. The sources can be from the external sources, the sources from database, sources from file, sources from internally. And then these you will collect all the data from these sources, and these sources, the translations and integration can be done. And after the translation, formatting, and integration, the data warehouses gives all the data to the decision support environment so that they can help in making decisions. The two-level architecture is one of the data warehouse layers which separates physically available sources and data warehouse. This architecture is not expandable and also not supporting a large number of users. It also has connectivity problems because of network limitations. A two-tier architecture includes a staging area for all data sources before the data warehouse layer by adding a staging area between the sources and the storage repositories. You ensure all data loading into the warehouse is cleansed and in the appropriate format. This is the three-tier architecture. In three-tier architecture, you will find the operational environment, the expanded data warehouse, the selection and integration, the data management, the translation and integration, and a decision support environment. So, in three-tier level architecture, it's the most widely used architecture of data warehouse. It consists of the top, middle, and bottom tier. Bottom tier, it is the database of the data warehouse servers. It is usually a relational database system. The data is cleansed, transformed, and loaded into this layer using backend tools. It includes data extraction, get data from multiple heterogeneous and external sources, data cleaning, detects errors in the data and rectify them when possible. Data transformation, convert data from legacy or host format to warehouse format. Load, sort, summarize, consolidate, compute views, check integrity, and build indices and partitions. Refresh, propagates the updates from the data sources to the data warehouse. Middle tier, it is the application layer giving an abstract view of the database. The middle tier in data warehouses is an OLAP server which is implemented using either ROLAP or MOLAP model. This layer also acts as a mediator between the end user and the database. It arranges the data to make it more suitable for analysis. Top tier represents the front end client layer. It is where the user accesses and interacts with the data. It could be query tools, reporting tools, managed query tools, analysis tools, and data mining tools. So basically, a top tier is a front end client layer, a middle layer is a application layer, and a bottom tier is a database. So are you understanding? There are the three tier in it: bottom, middle, and top. Bottom is the database, middle is the application layer, and top tier is a front end tier. You can access and interact with the data. This is the overall data. Bottom tier data warehouse server, मिडिल टीयर ओलैप सर्वर एंड टॉप टीयर फ्रंट एंड टूल्स. सो आप देख सकते हो ये 3 टीयर्स के हिसाब से ही बनाया गया है. सबसे नीचे सारे डेटाबेसेस हैं, ऑपरेशनल डेटाबेस है, एक्सटर्नल सोर्सेज है, और you can extract, clean, transform and load fresh data from these external sources and operational database. बॉटम टेयर हमारा डेटा वेयरहाउस सर्वर है जहाँ पे मॉनिटर किया जा रहा है, एडमिनिस्ट्रेटिव किया जा रहा है, मेटा डेटा रिपोजिटरी को तैयार किया जा रहा है, डेटा मार्ट और डेटा वेयरहाउस है. मिडिल टेयर में ओलैप सर्वर है और टॉप टेयर में फ्रंट एंड टूल्स हैं लाइक डेटा माइनिंग टूल, एनालिसिस टूल, क्वेरी रिपोर्ट टूल. तो ये हमारे जैसे कि हमारा एक लेवल ऑफ मैनेजमेंट होते हैं उस तरीके से ये इसमें काम करते हैं. नेक्स्ट, डेटा वेयरहाउस मॉडल्स. So yes, we are going to learn about some data warehouse models. So data warehouse models, enterprise warehouse models. सबसे पहला जो मॉडल है हमारा डेटा वेयरहाउस का वो हमारा enterprise warehouse models ही है. So an enterprise warehouse models collects all of the information about subjects spanning the entire organization. It provides corporate-wide data integration, usually one or more operational systems or external information providers, and is cross-functional scope. It consists of summarized data and its range in size from gigabytes, terabytes, or beyond. It is implemented on traditional mainframes, computer, super servers, parallel architecture platforms, and it takes years to design and build. तो ये जो सबसे पहला हमारा डेटा वेयरहाउस मॉडल है ये एक तरीके से सारी इंफॉर्मेशन को कलेक्ट करता है. एंड यस, it takes years to design and build. It has summarized data, it uses some cross-functional scope, it has some traditional mainframes and also corporate-wide data integrations. Second is data mart. A data mart contains a subset of corporate-wide data that is of value to a specific group of users. Example, Marketing data mart contains details about customers, items, and sales. It is implemented on low-cost departmental services, Unix and Linux. It involves complex integrations in long run. It is categorized into two sources of data: independent data marts, data captured from one or more operational systems, or external information on geographic area. Dependent data marts is a source directly from enterprise data warehouses. So you can also categorize these two sources of data in our independent data marts and independent data marts. Third is virtual warehouse model. A virtual warehouse model is a set of views over operational databases. It is easy to build but requires excessive capacity on operational database servers. Top-down approach, it is systematic solution and minimize integration problems. It is expensive, takes long time to develop, lacks flexibility due to difficulty in achieving consistency. Bottom down approach is that it is used to design, development and deployment of independent data marts, provides flexibility, low cost and rapid return of investment. So basically this virtual warehouse models follow the two approaches, that is top down approach and bottom down approach. Top down approach minimizes the integration and bottom down approach designs the development. Recommendation approach for data warehouses, you can see it's define a high level corporate data module. So the model is refinement, enterprise data warehouse, data mart and data mart, distributed data marts and multi-tier data warehouses. So आप देख रहे होंगे कि किस तरीके से डेटा वेयर हाउस डेवलपमेंट की अप्रोच है, ये अप्रोच किस तरीके से की जा रही है डिफाइनिंग अ हाई लेवल कॉर्पोरेट डेटा मॉडल को. यू कैन सी इन दिस पिक्चर है. आप इस पिक्चर को देख के समझ सकते हो तीन चीज़ों 4 थिंग्स की रिक्वायरमेंट है: मल्टी टियर डेटा वेयर हाउस की, एंटरप्राइज डेटा वेयर हाउस, डिस्ट्रीब्यूटेड डेटा मार्ट्स की और हाई लेवल कॉर्पोरेट डेटा मॉडल की. ये सारे मॉडल्स रीडिफाइन होकर डेटा मार्ट में होते हैं और ये कुछ अप्रोचेस को फॉलो करते हुए मल्टी टियर डेटा वेयर हाउस को, एंटरप्राइज डेटा वेयर हाउस को डेटा प्रोवाइड कराते हैं. सो व्हाट आर द डेटा मेटा डेटा मॉडल्स. मेटा डेटा क्या है? Metadata are data about data. It represents warehouse objects when used in data warehouses. It is created for the data names and the definitions of data warehouses. It is created and captured for extracted data, sources of extracted data, and it is added by cleaning or integration processes. So metadata repositories are placed in the bottom of the data warehouse architectures. It is used as directory to help decision support system. Analysts locate the content of data warehouses. It serves as a guide to algorithms used for summarizations. Metadata should be stored and managed persistently. A metadata repository consists of data warehouse structures. It includes data warehouse schema, view, dimensions, hierarchies, and derived data definitions, as well as data mart locations and contents. So basically metadata is a data about the data and it helps in various decision support system, extracting the data, cleaning or integration, metadata repositories, and guide to algorithms. And these metadata repositories consist of data warehouse structures. Second, operational metadata. It includes data lineage, a history of migrated data and sequence of transformations, currency of data and monitoring information, error reports and audit trails. Third, metadata repositories includes algorithm used for summarization, which has some measures and dimension definitions, algorithms, data on partitions, subject areas, aggregations, summarizations, and predefined queries and reports. So these repositories consist of algorithms also, which is used for summarization. Fourth, it also consists of mapping from operational environment to data warehouses. It includes databases and their contents, their descriptions, data partitions, data abstractions, cleaning, and security. So the operations which is performed on the data warehouses, they have to be mapped by these metadata repositories. Data related to system performance, it includes indices and profiles that improve the data access and retrieval performance, scheduling of update and application cycles. Business metadata, it includes business terms and definitions, data ownership information, and charging policies. So all these are the all these are the all these are the things which is consist all these are the metadata repositories consist of these things. जो भी metadata repository है, जो भी जहाँ पे भी डेटा का about data things stored होती हैं, वहाँ पे ये सारी चीज़ें होती हैं. वहाँ पे आपको business metadata भी मिलेगा, वहाँ पे आपको algorithms मिलेंगी use for summarization, वहाँ पे आपको operational metadata मिलेगा, data related to system performance मिलेगा, and also there are some of the डेटा वेयर हाउस स्ट्रक्चर भी आपको मिलेगा जो कि बहुत इंपॉर्टेंट है. सो ऑल दीज थिंग्स आर इन दी डेटा मेटा डेटा रिपोजिटरीज. नाउ डेटा वेयर हाउस मॉडलिंग क्या होती है? Our data warehouse and OLAP tools are based on a multi-dimensional data model. This model views in the form of data cube. Here are some of the schemas for multidimensional model. A data cube allows data to be modeled and viewed in multiple dimensions. It is defined by dimensions and the effects. So whenever a data warehouse modeling is to be done, there are some of the tools required for this multidimensional data modeling, and these models are used in the form of data cube. And the data cube is defined by some of the dimensions and the effects. Dimensions can be considered as a perspectives or entities with respect to which an organization wants to keep records. मतलब जो भी आपकी एंटिटीज़ हैं जहाँ पे आपके ऑर्गेनाइजेशन को रिकॉर्ड कीपिंग करनी है, वो सारी एंटिटीज़ को डायमेंशंस कहा जाता है. फॉर एग्जांपल, द सेल्स डेटा वेयर हाउस हैज डायमेंशंस लाइक टाइम, आइटम, ब्रांच एंड लोकेशन. जो भी सेल हुई, किस टाइम पे हुई, क्या आइटम हुआ सेल, क्या ब्रांच थी, क्या लोकेशन था. So all these are considered as entities for the data warehouse modeling. Dimensions को हम consider करेंगे. It is specified by users or experts and adjust data. तो dimensions जो है वो हमारी किसी experts के थ्रू या किसी user के थ्रू ही specify की जाती हैं. Facts क्या होते हैं? It is a numeric measures and analyze the relationships between dimensions. तो जो भी हमारे numeric measures हो गए या तो चीज़ें analyze करने के लिए काम में आई, वो भी उस relationship को जो हमारे dimensions के बीच में है. For example, sales data warehouse includes sales amount in terms of dollars sold or units sold, है ना. So the data cube is a metaphor for multidimensional data storage. The actual storage of such data may differ from its logical representations, and the data at different degrees of summarization is referred as cuboid. The cuboid that holds the lowest level of summarization is called the base cuboid, and the cuboid that holds the highest level of summarization is called apex cuboid. So basically क्यूब को हम एज अ मेटाफर कंसीडर करते हैं और एक्चुअल रिप्रेजेंटेशन के लिए हम एक्चुअल स्टोरेज ऑफ डेटा को देखते हैं. पर अगर हमारी डिफरेंट डिग्रीज में समराइजेशन हुआ है डेटा का, तो उसको हमने क्यूबॉइड की फॉर्म में डिफाइन कर दिया है. और अगर कोई लो लेवल ऑफ समराइजेशन है तो बेस क्यूबॉइड बनता है, और अगर हाईएस्ट लेवल ऑफ समराइजेशन है तो एपेक्स क्यूबॉइड बनता है. नाउ स्कीमाज आर देयर. अब बहुत सारे स्कीमाज को फॉलो करता है डेटा वेयर हाउस डेटा मॉडलिंग. स्टार स्कीमाज हो गई, स्नोफ्लेक्स हो गया, फैक्ट कॉन्स्टेलेशन हो गया. स्कीमाज फॉर मल्टी डायमेंशनल मॉडल्स आर लाइक ER डेटा मॉडल इज कॉमनली यूज्ड. एंटरप्राइज रिसोर्स मॉडल इज यूज्ड इन डिजाइन ऑफ relational database where database schema consists of a set of entities and the relationships between them. The most popular data model for a data warehouse is multidimensional data that consists of star schema, स्नोफ्लेक स्कीमा एंड फैक्ट कॉन्स्टलेशन स्कीमा। तो जो ईआर मॉडल होते हैं हमारे, जो सिंपलेस्ट फॉर्म में बनते हैं, वो सिर्फ डेटाबेस स्कीमा को फॉलो करते हैं और उसमें कुछ सेट ऑफ एंटिटीज होती हैं, कुछ रिलेशनशिप्स होती हैं। पर जो मॉडल, पॉपुलर मॉडल डेटा वेयर हाउस से हैं, वो मल्टी डायमेंशनल डेटा को फॉलो करते हैं। और वो जो मल्टी डायमेंशनल डेटा होता है वो इन स्कीमास को फॉलो करता है। स्टार स्कीमा हो गए, स्नेफलेक हो गए, ये सारी चीज़ें उस मल्टी डायमेंशनल डेटा में होती हैं। अब स्टार स्कीमा क्या होता है? It established the relationships between the fact table and any one of the dimensional tables. It has single fact table connected to dimensional tables like a star. It has one fact table and is associated with numerous dimensions table and depicts a star. So basically स्टार स्कीमा को क्या बताया है? एक फैक्ट टेबल के रिलेशनशिप्स के बारे में बताया है, और जो भी सिंगल फैक्ट टेबल कनेक्ट होती है डायमेंशन टेबल से, हम उसको स्टार बोल देते हैं। एंड दैट फैक्ट टेबल इज एसोसिएटेड विद द न्यूमरस डायमेंशंस एंड डिपिक्ट्स अ स्टार। So yes, next is the star schema diagram for sales data of the company with respect to 4 dimensions like item, time, branch and location। तो आप देख रहे हो पूरा प्रॉपर स्टार की फॉर्म में ही ये डिजाइन है। टाइम डायमेंशनल टेबल दे रखी है, सेल्स फैक्ट टेबल दे रखी है, आइटम डायमेंशनल टेबल दे रखी है, लोकेशन डायमेंशनल टेबल दे रखी है और ब्रांच डायमेंशनल टेबल दे रखी है। तो हर एक टेबल को, हर एक 4 डायमेंशंस को एक अलग तरीके से बताया गया है, बिल्कुल प्रॉपरली डिफाइन किया गया है स्टार स्कीमा डायग्राम में। सो ईच डायमेंशन रिप्रेजेंटेड विद ओनली वन डायमेंशनल टेबल। Dimension table contains set of attributes. Fact table at center and it contains key to each of 4 dimensions. Fact table contains attributes like dollar sold and unit sold. So this is the example of star schema diagram for sales data of a company with respect to the 4 dimensions. Now moving towards another schema, that is a snowflake schema. It is the extension of star schema. Large dimension tables are normalized into multiple tables. The normalization split up the data into additional tables. There is relationship between the dimension tables and it has to do joins to fetch the data. So in diagram, item dimensional table is normalized and split into the 2 dimensional table, that is item and supplier table. So स्नोफ्लेक स्कीमा क्या है? एक एडवांस वर्जन है, एक एक्सटेंशन वर्जन है स्टार स्कीमा का, और इसमें लार्ज डायमेंशन टेबल को भी मल्टीपल टेबल्स में डिफाइन कर दिया है। सो आइटम डायमेंशनल टेबल कंटेन्स एट्रीब्यूट्स लाइक आइटम की, आइटम नेम, टाइप, ब्रांड एंड सप्लायर की। एंड सप्लायर डायमेंशन टेबल कंटेन्स दी एट्रीब्यूट्स लाइक सप्लायर की एंड सप्लायर टेबल। सो एक्सटेंशन दे दिया गया है कि आइटम में सप्लायर टेबल का, आप इस डायग्राम में देख सकते हो। अभी तक हमारे पास टाइम डायमेंशनल टेबल थी, आइटम डायमेंशनल टेबल थी, लोकेशन डायमेंशनल टेबल थी और ब्रांच डायमेंशनल टेबल थी। तो अब इसका एक एक्सटेंशन हो गया, आइटम में एक सप्लायर की ऐड हो गया कि सप्लायर डायमेंशनल टेबल क्या है, और लोकेशन में भी सिटी को डिफाइन कर दिया है कि सिटी के अंदर उसका स्टेट, उसकी कंट्री को फॉलो कर दिया है। तो एक तरीके से एक्सटेंशन हो गया है हर एक डायमेंशनल टेबल में। So this is the snowflake schema diagram for sales data of company. You can see this. Here the item table has another related supplier dimensional table, and location dimensional table has another city dimensional table. Next is fact constellation. Fact constellation is a measure of online analytical processing, which is collection multiple fact tables sharing dimensions tables viewed as a collection of stars. It consists of multiple fact tables and this schema is also known as galaxy schema. आप इसके नाम से देख रहे होंगे कॉन्स्टेलेशन, और कॉन्स्टेलेशन कहाँ पर मिलते हैं? गैलेक्सी में पाए जाते हैं। तो हम इसको बता सकते हैं कि इस स्कीमा को हम गैलेक्सी स्कीमा भी बोलते हैं। इन द फॉलोइंग डायग्राम इट कंसिस्ट ऑफ 2 फैक्ट टेबल्स, सेल्स एंड शिपिंग. Sale fact table is same as star schema. Shipping fact table has 5 dimensional, namely item key, time key, shipper key, and location. It contains two major, namely dollars sold and units table. It is possible for dimensional table to share between the fact tables. Here you can see the example. Fact constellation schema for sales data of a company. अब आप देख रहे हो टाइम डायमेंशनल टेबल को अटैच किया गया है शिपिंग फैक्ट टेबल से. कितने टाइम पर हुई शिप, कितनी किस लोकेशन पे हुई, कितने डॉलर्स कॉस्ट हुए, कितना शिप्ड हुआ. सेल्स फैक्ट टेबल को कनेक्ट किया गया है ब्रांच से और लोकेशन से, लोकेशंस कितनी हुई. और आइटम्स को एक अलग वे में रखा है, उसको शिपिंग टेबल से कितने आइटम्स कलेक्ट हुए. तो एक शिपिंग फैक्ट टेबल अलग से बना दी गई है इन सबको, सारे चीज के फैक्ट्स को देखने के लिए. और एक शिपर डायमेंशनल टेबल्स और अलग से बना दी गई है. सो फैक्ट कॉन्स्टलेशन स्कीमा डायग्राम इज ऑल्सो कंसिडर्ड एज अ गैलेक्सी स्कीमा. So the difference between star, snowflake and fact constellation schema is that in terms of elements you can see in star schema single fact table connected to multiple dimensions है ना. एक single था, star की form में था, और multiple dimension tables with no sub dimensional tables. But in snowflake single fact table connects to the multiple dimensional tables and that connects to multiple sub dimensional tables. But in fact constellation schema multiple fact tables connects to multiple dimension tables that connects to multiple sub dimensional tables. In the term of normalization, it is denormalized, and snowflake schema is normalized and fact schema is normalized. In the terms of number of dimensions, star schema has multiple dimension tables mapped to a single fact table, whereas snowflake schema has multiple dimension tables mapped to multiple dimensional tables, and fact schema has multiple dimensional tables mapped to multiple fact tables. So आपने देखा ये मल्टीपल डायमेंशनल टेबल्स को मैप करेगा सिंगल फैक्ट टेबल, उधर मल्टीपल डायमेंशनल टेबल्स हैं और इधर मल्टीपल डायमेंशनल टेबल्स मैप टू मल्टीपल फैक्ट टेबल्स. डेटा रिडंडेंसी की बात करें तो स्टार स्कीमा की डेटा रिडंडेंसी हाई रहती है, स्नोफ्लेक की स्कीमा लो रहती है और फैक्ट कॉन्स्टलेशन स्कीमा की भी लो रहती है. परफॉर्मेंस की बात करें तो स्टार स्कीमा है फ्यूअर फॉरेन कीज रिजल्टिंग इन इंक्रीज्ड परफॉर्मेंस, decreased performance compared to star schema from higher number of foreign keys, and fact constellation schema is decreased performance compared to star and snowflake because it is used for complex data aggregation. कॉम्प्लेक्सिटी की बात करें तो स्टार स्कीमा बहुत सिंपल है, easy to design and understand. स्नोफ्लेक इन कंपैरिजन टू स्टार थोड़ा कॉम्प्लिकेटेड है, थोड़ा चैलेंजिंग है अंडरस्टैंड करने के लिए. और फैक्ट स्कीमा इज मोस्ट कॉम्प्लिकेटेड टू अंडरस्टैंड एंड रिजर्व्ड फॉर हाईली कॉम्प्लेक्स डेटा स्ट्रक्चर्स. सो these are the difference between the star, snowflake and fact schema. स्टोरेज यूसेस की बात करें तो हायर डिस्क स्पेस ड्यू टू डेटा रिडंडेंसी, लोअर डिस्क स्पेस ड्यू टू लिमिटेड डेटा रिडंडेंसी, एंड फैक्ट स्कीमा में तो बहुत ही लो डिस्क स्पेस यूसेज होता है एज कम्पेयर टू द लेवल ऑफ सोफिस्टिकेशन ड्यू टू द लिमिटेड डेटा रिडंडेंसी. डिजाइन लिमिटेशंस की बात करें तो वन फैक्ट टेबल ओनली, नो सब डायमेंशंस. अगर स्नोफ्लेक में देखें तो ओनली वन फैक्ट टेबल एंड मल्टीपल सब डायमेंशंस आर परमिटेड. और फैक्ट कॉन्स्टलेशन स्कीमा की बात करें तो मल्टीपल फैक्ट टेबल्स परमिटेड, only first level dimensions are permitted. So here are some of the operational database systems and data warehouses. Operational system assist a company or organization in its day-to-day business. Its applications and data are highly structured and provide immediate focus on business functions with the help of OLTP. It required to support a large number of transactions on a daily basis. Operational data stores small, focusing the database on a specific business area and eliminating database overhead in areas such as indexing. Data warehouse system is organized around the trends or patterns in those events set by operational systems. Data warehouse focuses on business needs and requirements. It develops ideas for changing the business rules to make these events more effective. So ऑपरेशनल सिस्टम्स में और डेटावेयर सिस्टम्स में यही अंतर है कि वो ऑपरेशनल छोटे छोटे चीज़ों पे फोकस करता है, लार्ज नंबर ऑफ ट्रांजैक्शन पे फोकस करता है, डे टू डे बिजनेस पे फोकस करता है। बट डेटावेयर हाउस हमेशा ट्रेंड्स को फॉलो करता है, बिजनेस रूल्स को चेंज करने की और बेसिक बिजनेस नीड्स पे फोकस करता है। The multiple purposes are it minimize the impact of reporting and complex processing on operational systems. It preserves operational data from reuse after the data has been purged from the operational system. It manages the data based on time, allowing the user to look back and see how the company looked in the past versus the present. It provides a data store that can be modified to conform the way the user view the data. It unifies the data within a common business definition and offering one version of reality. So the difference between the operational database systems and data warehouses are in terms of the size and the content, operational systems are small and data warehouse systems are large. In performance, speed in nature, so the difference between in the performance, speed in nature, slow as the request of data is based on query, content focus, small work areas, cross functional areas, tools like typical structure and deals with less number of tools, and it in data warehouses various tools and supports the types of the data. So overall you can see the difference between operational database systems and data warehouses. So thank you all of you. From this lecture I think you understand the data warehouses and the introduction to data warehouses. Take care all of you. Thank you.